Okay, in this video we're going to be taking a look at factors, which we discussed earlier, and we'll do a few more examples of that. We're going to look at the primes up to 50, and then woohoo, we get to do prime factorization, which has so many uses in math, and I love it. It's kind of fun to do. Okay, so let's start with finding factors. We call this, so we remember that the factors are just a list of numbers, and there are a few of them. So it's the numbers that go into 72 evenly. So if we start, we know that 1 is always invited to that party and its partner would be 72. So then you just start building from this side until these two ends meet. So does 2 go into 72? Oh yeah. So 2 times what? That would be 36. So that's 2's partner. Does 3 go into it? 7 plus 2, 9. I added up the digits. Yep. So isn't that nice that we had that divisibility shortcut? So 72 divided by 3, you're going to have to divide that out, but I'll just tell you, you would get 24. So that's its partner, does 4. If you divide it out, yep, 4 goes into 72. And it goes 18 times. And does 6, I'm running out of room here. Does 6 go into 72? Yes, it does, and it goes 12 times. Now, our ends haven't met, so I'm going to have to squeeze some guys in here. Does 7? Well, we don't know. No, 7 doesn't go into 72. You can kind of divide that out and say, nope. Does 8? Oh, yeah. 8 goes in there, and its partner is 9. So let me rewrite this a little bit so it looks a little bit nicer. We have 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. Woo-hoo-hoo. You're saying, that's not so few. Well, it's not so few, but it's a lot less than infinitely many. So those are the factors of 72. Let's take a look at, let's do 100, and then we'll stop at that. The factors of 100, I'm going to leave myself a lot more room. I don't think I'll need that much more room. 1, yeah, and there's his partner. Those guys are always there. 2 and 50. 3, no. 4, yes. 4 times 25. 5, yeah, it ends in a 0. 5 times 20. 6, no, because 3 is not there. 7, have to divide it out. Can I just tell you it's not going to? 8, well, have to divide that out. And if you do, I'm just going to tell you, nope, it's not going to divide evenly. 9, if 3 is not there, we don't have to worry about 9. 10, oh yeah, 10. And 10 times 10 is 100. So we know that these two ends have met, and we know we're finished. So that's just finding factors. Next step. What I want to do, take another look at primes. You want to be familiar with the prime numbers because that's going to become important when we do prime factorization. So let's take a look at the primes, the small ones. 1, no, 1's not a part of either primes or composites. So the first prime we get to is 2, the only even prime. 3, its only factors are 1 and itself. It only has 2 factors. 5, 7, 9's not. I have a question to ask you before we go further. After we include 2, do we even have to think about any of the other even problems, even numbers? 4, 6, 8, 10. No, we don't even have to consider those because if they're even, we know 2 goes into them. So we're only considering odds, but not all odds are primes. So let's take a look at the next odd. The next odd would be 9. Is 9 prime? Nope. Because besides 1 and 9, 3 goes into it. The next odd is 11. Yep. 13. 15. Nope. 3 and 5 go into it. So 15's not. 17. 19. And I'm just going to complete the list up to 50. So these numbers especially, 2, 3, 5, 7, 11, 13, 17, and 19, you need to recognize those as those very special primes. In the 20s, we have 23, and 29. In the 30s, 31 and 37, and the 40s have 3. 41, 43, and 47. Okay, so if I would keep that list of primes handy to look at, especially those under 20, so you'll know what's a prime, because in prime factorizations we know we can stop when we get to a prime. Okay, let's keep going. Let's stop here. We'll have a whole video for prime factorization because it is such fun. Okay, I'll see you guys in the next video.